There is a very strange object flying past our sun. We don't exactly know what this thing is or what it's doing. We can't even see it anymore. But we have been watching this object very closely for months. We've given it a name, 3I Atlas, and a title, Interstellar Comet. In just 4 months, there have been nearly 100 research papers published on it, but some claims can sound pretty insane. So today we're cutting through the noise to get to the bottom of everything you actually need to know about 3I Atlas. Let's talk about its journey. Right now, 3I Atlas is making its closest approach to the Sun, a phase we call perihelion. It will pass within about 1.4 astronomical units of our star, which is just inside the orbit of Mars. This will be the time of peak activity. As it gets hotter, material from its surface gets blasted into space. That's normal for a comet. We call this process sublimation. Sublimation gives a comet its distinct look, a fuzzy halo called the coma, made of gas and dust, and a long tail, created by solar wind pushing that material away from the comet. It's a spectacular piece of cosmic ballet. Unfortunately, we don't get to see this happening to 3I Atlas as it flies through its peak exposure because our view is completely blocked by the glare of the sun. So, while we wait for it to reappear, we have an opportunity to investigate how it got here in the first place. And this is a deeply fascinating story. We have been tracking 3I Atlas since July 2025. It was officially spotted by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is a network of telescopes that scan the night sky for moving objects. And that is what they saw, just another moving object. But then they noticed something weird about this one. It's moving too fast. Everything in our solar system orbits the sun, trapped by its gravity. The closer you get to the sun, the faster you have to move to stay in orbit. But if you move fast enough, you can break free completely and fly out into interstellar space. When astronomers clocked the velocity of this new object, they were shocked. It was moving at 58 kilometers per second, way out near the orbit of Jupiter. At that speed, it was clear this object was going to blow straight past the sun and just keep on going. We call this a hyperbolic trajectory, meaning this thing had come from interstellar space, and that's where it was going to return. This is when the name 3I Atlas came to be. Third interstellar object, which means there were 2 before it. You probably know Oumuamua, the first ever identified interstellar visitor. And then there was the often overlooked 2I Borisov, which basically just acted like a normal comet. There are 3 big differences between 3I Atlas and its interstellar siblings. One is size. It's literally much bigger. Oumuamua was up to 400 meters across, Borisov was as wide as 1 kilometer, but 3I Atlas could be up to 5.6 kilometers in width. 2 is speed. Atlas travels at about double the velocity of Oumuamua and Borisov. And 3 is the direction that the object came from, and this is the really weird one. Oumuamua and Borisov came in from the general direction that our solar system is moving through the galaxy, so as much as they hit us, we also kind of ran into them. Now 3I Atlas is not another head-on collision. This one is a T-bone. It's coming in on a side angle, in almost perfect alignment with the disk of planets in our solar system, which we call the plane of the ecliptic. Most things in our solar system are on this flat plane. Even Pluto, known for its tilted orbit, is only off by 17 degrees. 3I Atlas is only 3 degrees off. For an object that could have come from any direction in 3-dimensional space, hitting us almost perfectly side-on is a very big coincidence. But that leads us into an even bigger question. Where did 3I Atlas come from? Well, we know that it came from the direction of the galactic core. The core is bright because it's full of stars, packed together much more tightly than the ones in our neighborhood. But to really understand its origin, we need to flip the galaxy to a side view. Most of the stuff in the Milky Way is in a thin disk, but there are also things that hang out above and below it, in an area we call the thick disk. It's a lot less crowded there, so things tend to hang out undisturbed for very long periods of time, and that's where astronomers believe 3I Atlas came from. This ancient region of space, which could make it as old as 7.6 billion years, nearly twice the age of our own planet. Now, we'll probably never be able to trace its journey all the way back, but astronomers have managed to backtrack over 10 million years. They identified 93 stars the object would have encountered, but over that entire time, the closest it came to any of those stars was a distance of 0.3 light-years, and right now, 3I Atlas is just 1.4 AU away from our own sun. Now, let's talk more about how 3I Atlas approached the sun. Even though it was officially discovered on July 1st, it was actually spotted for the first time on May 7, 2025. It showed up in images from the TESS satellite, an observatory that looks for new planets in other star systems. For about a month, TESS just happened to be looking in the direction of 3I Atlas. This gave us the opportunity to track the object as it moved through the orbit of Jupiter and measure how its brightness changed over time. As the object traveled about 1 AU closer to the sun, astronomers expected its perceived brightness, or flux, to increase by a factor of 1.5. But data from TESS showed the flux actually increased by a factor of 5. That's how we know this isn't an asteroid. It must be a comet forming its coma of gas and dust, which is reflecting all that excess light. Only there are two weird things about this observation. One has to do with the polarization of light. When light from the sun hits the coma, it scatters. If it scatters to the side, we call that positive polarization. If it bounces straight back, that's negative polarization. Most objects in space, even interstellar ones like 2I Borisov, have a mostly positive polarization, but 3I Atlas is negative. In fact, it has the most extreme negative polarization of any object ever discovered. That is pretty weird. And the second surprising thing was that the coma even existed at all. Remember, this was between May and June, when 3I Atlas was still way out beyond the orbit of Jupiter. It's cold out there. It's so cold that comets from our solar system, which are typically made of water ice, are still frozen solid at that distance. They don't usually start sublimating until they're much closer to the sun. But as we observed 3I Atlas, we learned its coma was actually dominated by CO2 gas. It had some water vapor, but the ratio of CO2 was much higher. Basically, the opposite of what we're used to. If you've ever seen dry ice, that's frozen CO2. It sublimates instantly at warmer temperatures, creating a cloud of gas. That's what 3I Atlas was doing way out in space, because CO2 ice melts at a much lower temperature than water ice. As it approached the sun, we saw that ratio of CO2 and water begin to flip. By late September, it began to release a massive amount of water vapor, more than we'd expect even from a normal comet at this distance. We've never seen so much water vapor appear so suddenly. The same thing can be said for metal in the coma. Over the summer, astronomers detected nickel, but no iron. This is strange because nickel and iron are formed together inside dying stars and are typically found together. So when we see a lot of nickel but no iron, we wonder where the iron went. It's also weird to see any metal sublimating so far from the sun. The likely explanation is that the massive release of CO2 was dragging nickel atoms along with it, but that still doesn't account for the missing iron. Now, just like water vapor, iron did eventually make a sudden appearance. By late September, astronomers detected it for the first time, and very quickly, the ratio of nickel to iron changed to a more normal combination. So 3I Atlas is becoming more normal over time, but it's getting there in a very strange way. Now, let's talk about tails. This is another area where 3I Atlas behaved differently. The first time we saw a tail forming, it was pointing in the wrong direction, towards the sun. This is unusual, because the tail is an effect of the solar wind, which blows away from the sun. It's possible that, because the object began sublimating so far out, the solar wind just wasn't strong enough yet to push the cloud of gas and dust away. By September, a short, fan-shaped tail facing away from the sun had developed, which is pretty normal. Not all comets have long, streaking tails. Around this time, we got our closest possible observation of 3I Atlas, not from Earth, but from Mars. On October 3rd, the object passed within 0.19 AU of the planet. And this is lucky for us, because we have a lot of cameras on and around the red planet. Here is a photograph taken by the Perseverance rover. It's not a great picture. To see this much light, the camera had to take long exposures, which were then stacked, creating more of a streak than a defined object. And here is another image from the ExoMars probe. We can see the object a little more clearly, but still not enough to distinguish the bright coma from the surface of the object itself. To get that fine detail, we would need a photo from NASA's Mars Reconnaissance Orbiter. Unfortunately, at the time we are making this video, that image has not been released, if it was ever taken at all, due to a US government shutdown. But time is something we have right now, because the sun is going to continue blocking our view of 3I Atlas until early December, at which point we'll be able to study the effect the sun had on the object. At this point, 3I Atlas will be well on its way out of the solar system. But there is just one more close encounter still to come. On March 16, 2026, the object will fly within 0.36 AU of Jupiter. We have one camera there, on a probe called Juno. It will have a chance to take one last image of 3I Atlas before it disappears. At this distance, the object will be cooling down and less active, but it could be changed by its exposure to the sun, and that will add an extra layer of understanding to these interstellar objects. It's entirely possible that a lot of these strange characteristics didn't even come from the place where the object was formed. It's just an accumulation of weird stuff that it picked up along the way. For now, we can only wonder, but more answers and probably more questions are soon to come.